A NASA spacecraft has detected.
Well, NASA's most distant spacecraft did phone home, but the conversation, if you will, was a little hard.
In the vast frigid darkness beyond the outer planets, where sunlight is a feeble echo of what it is on Earth, NASA's Voyager probes have been silently drifting for decades. Initially launched to study the giant planets of our solar system, both Voyager 1 and Voyager 2 have continued their missions well past their expected lifespans, pushing farther than any human-made object in history. Now, decades after their launch, one of these probes has made a discovery at the edge of the solar system so unexpected, so puzzling, that it has left even the most seasoned scientists at NASA stunned. Before we start, smash the like and subscribe buttons for more updates. The edge of the solar system is not a well-defined boundary. It is more like a transitional region, a liminal zone between the sun's domain and the interstellar medium. This region is known as the heliopause, the theoretical boundary where the solar wind is no longer strong enough to push back against the interstellar medium. It marks the end of the sun's influence and the beginning of the vast galactic wilderness. Voyager 1 first crossed the heliopause in 2012, followed by Voyager 2 in 2018. But what Voyager 1 recently detected on its journey through this distant region has upended long-standing theories about the boundary that separates our solar system from the rest of the galaxy. As the spacecraft journeyed deeper into interstellar space, its plasma wave instrument picked up something extraordinary: persistent, low-frequency plasma waves that were not aligned with any known models of the interstellar environment. Plasma waves are a key method by which scientists detect the density and temperature of charged particles in space. These waves travel through the ionized gas and can reveal the structure and behavior of plasma on a cosmic scale. What was shocking wasn't just the presence of plasma, after all space is filled with it, but the consistency, rhythm, and intensity of the waves Voyager 1 encountered. It was unlike anything observed before. The data indicated a surprising level of turbulence and density in what was expected to be a much calmer region. According to long-standing models, the interstellar medium just beyond the heliopause was thought to be relatively quiet and homogeneous. The presence of such intense and structured plasma waves suggests that this region is far more dynamic and complex than previously imagined. The plasma was not only denser than expected, but it also seemed to be pulsing with a regularity that defied easy explanation. What startled NASA scientists even more was that these plasma waves appeared to be disconnected from solar activity. In earlier observations closer to the heliosphere, plasma waves were often correlated with solar storms or coronal mass ejections. But the waves Voyager 1 was detecting came from a region where the sun's influence had already significantly waned. This implied that the source of the disturbance was not solar in origin, but something entirely new, possibly originating from deeper in the galaxy. One hypothesis is that Voyager 1 had entered a region of space where the galactic magnetic field behaves differently, perhaps due to some underlying anomaly or boundary in the interstellar medium itself. If true, this would imply that the structure of the galaxy's magnetic field is far more intricate than previously thought, and that the boundary between solar and interstellar space isn't a simple line, but a multi-layered dynamic zone where cosmic forces interact in unpredictable ways. Another possibility is that the probe has encountered the remnants of an ancient supernova. When a star explodes in a supernova, it ejects a massive amount of matter and energy into space. Over millions of years, this material disperses, but pockets of it can remain, creating eddies and whirlpools in the plasma that drift across the galaxy. If Voyager 1 has indeed wandered into such a remnant, it would be the first time humanity has ever directly sampled this kind of interstellar debris field, and it would provide invaluable data on the life cycle of stars and the conditions of interstellar space. Complicating matters is the fact that the instruments aboard Voyager 1 are aging. Designed in the 1970s, these instruments are remarkably robust, but they were never meant to function for nearly half a century. Yet here they are, still transmitting vital data from more than 15 billion miles away. Interpreting this data presents a formidable challenge. The signals are faint, distorted by cosmic radiation and weakened by the incredible distance. Still, the consistency of the plasma wave readings leaves little doubt that something extraordinary is happening. Perhaps the most intriguing implication of this discovery is the potential impact on our understanding of the heliosphere, the giant bubble created by the solar wind that envelops the entire solar system. The traditional view held that this bubble gradually tapers off and gives way to the interstellar medium at the heliopause. But the new data suggests a more jagged, turbulent transition, one marked by magnetic reconnections, particle interactions, and fluctuating plasma densities. This means the heliosphere could be more like a porous membrane than a sealed shell, allowing for a much more complex exchange of matter and energy with interstellar space than previously assumed. This has profound implications for the shielding effect of the heliosphere. Earth and the rest of the planets benefit from this solar bubble, which protects us from a significant portion of cosmic radiation. If the heliosphere is more permeable and variable, then the level of protection it provides might fluctuate over time. This could affect everything from the evolution of life on Earth to the future of manned space travel beyond the protective cocoon of the inner solar system. The discovery also raises questions about the fate of other solar systems. If our own heliosphere is this dynamic and unstable, then other stellar systems might be similarly affected. This means the boundaries of stars could be subject to violent interactions with the interstellar medium, shaping the development of planets and possibly influencing the emergence of life elsewhere in the galaxy. From a broader perspective, what Voyager 1 detected challenges the very notion of where the solar system ends. For decades, the heliopause was thought to be the final boundary, a clean break between our star's influence and the galaxy beyond. But if this boundary is as complex and active as the data suggests, then the line between here and out there becomes blurred. The solar system may not end at the heliopause, but rather fade into interstellar space through a chaotic, shifting zone of magnetic and plasma interactions. There's also the tantalizing idea that Voyager 1 is encountering the very beginnings of a galactic environment shaped by forces we have yet to understand. The persistent plasma waves could be the echoes of processes occurring hundreds or even thousands of light years away, carried across space like ripples across an immense ocean. If so, then Voyager is not just a traveler crossing a border, but a listener picking up the whispers of the cosmos. The implications stretch into the theoretical as well. If magnetic anomalies, interstellar turbulence, and residual shock waves from ancient events can create such disturbances in space, then our models of cosmic weather need to be rewritten. The idea of space weather has typically been associated with solar storms and their effects on satellites and power grids. But on a galactic scale, the same principles could apply, just on far longer timescales and with far greater energy. Such revelations are a powerful reminder of how little we truly know about the universe just beyond our doorstep. For all of our telescopes, satellites, and simulations, it is a 47-year-old spacecraft running on a fraction of the power of a light bulb that is giving us the most direct and surprising data about this mysterious frontier. And it's not just the discovery itself that is awe-inspiring, it's what it represents. The persistence of curiosity, the power of exploration, and the willingness to ask questions no one thought to pose before. What Voyager has detected is not just a strange plasma phenomenon. It is a gateway to rethinking our place in the universe. It challenges the assumption that we can neatly divide the cosmos into distinct regions and forces us to consider that even at the boundaries of our solar system, there is no true edge, only deeper layers of complexity. Each reading, each pulse of plasma, each signal from that tiny spacecraft millions of miles away is a piece of a puzzle far greater than anyone had imagined when Voyager first left Earth. Even though we may never send another mission into interstellar space for decades, Voyager has opened a door that cannot be closed. It has shown that the boundaries we once believed were clear and defined are in fact riddled with questions and strange phenomena. These recent plasma wave detections are not anomalies to be dismissed. They are the first clues in a new chapter of cosmic understanding. The interstellar medium is not empty. It is a realm of constant flux, a place where magnetic fields twist and churn, where remnants of stellar death continue to echo, and where unknown energies dance across unimaginable distances. And within this space, Voyager 1 drifts onward, a silent witness to the galaxy's hidden rhythms. There's a haunting beauty in knowing that this lonely spacecraft, built by hands that now belong to a previous generation, is still teaching us. That it continues to unveil the secrets of a region that was once beyond the reach of imagination. Voyager's latest detection is not just a scientific curiosity, it is a turning point. It signals that our exploration of space is far from over, and that the universe beyond the sun is not a silent void, but a living, breathing sea of unknowns. Each moment that Voyager continues its journey, it expands the frontier of human knowledge. It reminds us that the cosmos does not end where our solar system fades into shadow. It only begins anew, in a realm filled with mysteries as vast and beautiful as the stars themselves. If you liked this video, please give it a like and subscribe to our channel. Also, Leave your comments below and tell us. What are your thoughts on Voyager's shocking NASA detection? What do you expect? We want to hear from you. Thank you for watching, and see you next time.